Pavan. Myself is a Pavan. Today I am going to Nernest equation. So here to write the Nernest equation, so here the definition of the Nernest equation is algebraic sum of the single electrode potentials. Single electrode potential, that is called as what? Nernest equation. So here next one is, so to write the Nernest equation, so we need one chemical reactions. So here I am going to take one of the chemical reactions. I am not taking, so here the entire thing, just for example you can consider it. So here the zinc and copper electrode, zinc and copper electrode. So in this, zinc is, so here the value of zinc is minus 0.76, copper is positive 0.34 volt. So here based on these values, the highest reduction potential, we know that highest reduction potential values is always acts as a cathode, the lowest reduction potential values is acts as a anode, right? So now we are going to write one of the chemical reactions. This chemical reaction is, so in case of zinc, so here the anodic reaction, anode you are going to take. So here that anode means which loses electrons. So here the Zn2 plus 2 electron. So this process is called as what? Oxidation, we know that. And next one is cathode. Cathode, in this cathode the copper is acts as a cathode. So whatever the releasing of electron takes place from the anode, that electrons will gain by the cathode. So 2 electrons, and therefore it becomes as a copper. If you write overall reaction, these two electron cancel, and next zinc and Cu2 plus. So here Zn2 plus Cu. This one is, so here the overall reaction. This reaction I am going to take here. So here the zinc, and next how you write? Zn2 plus, that undergoes oxidation, and next copper, which undergoes a reduction, which gains electrons and it forms Cu. This is a reaction. This is a one reaction. By using of this reaction, we need to write the Nernest equation. What is the Nernest equation? So Nernest equation is, so we have one mathematical equation is there, that is E equal to, so here the E naught minus, so here the 2.03. So here the 2.303 RT by, so here the NF, so here the log of concentration of product by concentration of reactant. That is called as what? It is a Nernest equation. So using this reaction, using this chemical reaction, we need to write the Nernest equation. How we are going to write? So here for example E equal to, so E naught minus, so here the 2.303, so here the RT by, so here the NF, and log of concentration of product means this you need to take concentration of Zn2 plus and concentration of Cu divided by, this is a product. Concentration of reactant means we need to take concentration of zinc and concentration of, so here the Cu2 plus. So we know that, so what is the Nernest equation? So here the Nernest equation is, generally Nernest equation is used to, so here the used to calculate, so here the potentials of electrodes, so here the potentials or charges of electrodes only, This is the main definition of the, so Nernest equation. This is the main definition of the Nernest equation. Using of this quotation or definition, we need to write the Nernest equation. What it is? Used to calculate potentials or charges. For example, if you take this reaction, so this zinc will have the potential, we can calculate the Nernest equation. But this copper doesn't have any charge or potential, we can cancel it. The zinc also, it doesn't have any charge or potential, so we can cancel. This copper will have the, so charges and then. Therefore, the equation, the above equation will become E equal to E naught minus, so here the 2.303 RT by, so here the NF. Next one is what? Log of, so here the concentration of Zn2 plus divided by concentration of Cu2 plus. Now, so we need to write where, where E is what, E naught is what, and next one is what, R is what, and next T is what? So here the T is what? And next one is what? N. What is the N and what is the F? So if you take E, this is what it is, a single electrode potential, single electrode potential. And next E naught is what? It is a standard STD, standard electrode potential. R is gas constant. Gas constant. The value of this one is 8.314. T is absolute temperature. That is, we need to take 298 Kelvin. So N is number of valence electrons. F is Faraday. 1 Faraday equal to 96,500 coulomb. You can substitute all the values, 298 and gas constant value and this. So therefore this equation will become as E equal to, so E naught minus, so here this all value you can substitute, then 0.0591 divided by N you will get, and next log of concentration of Zn2 by here the concentration of Cu2 plus. This is the one equation. If using of zinc and copper electrode, this is a reaction. If you consider hydrogen electrode only, for example hydrogen electrode you consider, so here this hydrogen will act as anode itself. So therefore this anode which loses electrons, how many it will loses? 2 electrons it will loses. This process called as what? Oxidation. Therefore using of this reaction we can write the Nernest equation. So what is the Nernest equation? Nernest equation is, so here the E equal to E naught minus 2.303, so here the RT by, so here the NF. So here what you are going to write? Log of concentration of product by concentration of reactant. What is the product? Concentration of H plus whole square by concentration of reactant, means only hydrogen you are going to take. So what is the Nernest equation? Nernest equation is used to calculate the potentials or charges. So this hydrogen doesn't have any charge, this hydrogen we have. So therefore this equation will become as E equal to, so here the E naught minus can we substitute all this R value, T value and F value? You can substitute. R value is what? 8.314 and absolute temperature 298 Kelvin. Faraday is what? 96,500 coulombs. Then therefore the equation will become as 0.0591 by N. So here the log of, so what you are going to write? Concentration of H plus. Since, so here what is the since? Since the pH is, what is the pH definition? Negative logarithm of concentration of H plus. So substitute this one. So therefore the above equation will become as, so here the E naught, this minus into minus plus, it become plus 0.0591. So here the pH. This is the another equation. If you are considered, so for example this is a step 1. This is a step 1. So one equation you will get. What is the equation? This is the one equation. So this is a step 2. So here this is the second equation. And next one is step 3. If you consider zinc and hydrogen, so in this zinc will act as an anode, so it will loses 2 electrons. So electrons, and which gains 2 electrons, hydrogen will gain 2 electrons and it will gain so hydrogen gas. Using of this equation we need to write the Nernest equation, right, using of this reaction. So here in this, so we know that E equal to E naught minus, so here the 2.303 RT by NF. So here the log of concentration of this one. So concentration of Zn2 plus and concentration of hydrogen gas divided by, so concentration of zinc and concentration of, so here the H plus whole square. So here we know that Nernest equation is used to calculate the potentials or charges of electrode. Therefore this hydrogen that doesn't have any charges, this zinc also doesn't have any charges. Therefore the equation will become as E naught. So can we substitute all values? R value, here the R value, T value, here T value, and this all you can substitute, you will get of 0.0591. So divided by N. So here the log of, so here the Zn, concentration of Zn2 plus by concentration of H plus. So we know that standard hydrogen electrode, what is She? The standard hydrogen electrode is always assigned to be 0, or the concentration of H plus is equal to 1 unit. For liquids and solids, this condition you are going to take, these two conditions, it become as a 1. Therefore, you can cancel this one. Therefore, the end of the reaction is E naught. So here the 0.0591 by N. So here the log of concentration of Zn2 plus. Therefore, the Nernest equation is used to calculate only charges of zinc electrode, because the concentration of hydrogen, we need to take 1 unit, or standard hydrogen electrode, it become as a 0 value. That is the reason we are going to take. So this is the third equation. So using of this equation, this is the first equation, second equation is this, and third equation is this. So using of these three equations, we need to write different types of Nernest equation. This is the one equation, this is the second equation, this is the third equation, right? This is about the Nernest equation. Thank you.